friends, today we are going to discuss the first chapter in plus 2 computer science. Listen, the contents shown on the screen can be noted down for your reference. At the end of this session, there is an assignment for you which contains important questions based on this session. Okay, let's move on to the topic now. Structures and pointers. Look at your ID card or admission card issued by your institution, which contains name, admission number or register number, address, telephone number, blood group, height, fee structure, etc. Say for example, a register number. It is represented using the type int. It is used to represent integers, numbers without fractional part. Then name, it is represented using char type, char type, character array. Okay. Then height, it is represented using float type. It is used to represent fractional numbers. To represent this grouped data, C++ provides a facility to define new data types called user-defined data types. Structure is such a user-defined data type. See the definition. Structure is a user-defined data type to represent a collection of logically related data items. Logically related data items. Okay. See the structure definition. Struct student, brace open, int register number, char name, float height, brace closed with a semicolon. Okay. Here struct is a keyword used to define this structure. Student is the structure name or structure tag which encloses all these data. Okay. Struct student, int register number, char name, float height. Struct is the keyword. Student is the structure name or structure tag which encloses all the data items or data elements. Here, student is the new user-defined data type. Okay. Variable declaration and memory allocation. See the syntax. Structure name, variable name, semicolon. Also we can write struct structure name, variable name. Example, student S. Here S is the structure variable of type student. Student S1, S2. Here S1 and S2 are structure variables of type student. We can create any number of structure variables like this. This is one method for the variable declaration. A structure variable can be declared along with the definition also. See the example. Struct student, int register number, character name, float fee, and bracket closed with the variable S, and this S is the structure variable. Okay, here the structure variable is declared along with this structure definition. This is the second method. We can use both the methods for the variable declaration. Now we will discuss memory allocation. The definition of this student structure shows that its variable means yes, structure variable, okay, requires 18 bytes of memory. How can we calculate this? See the diagram. Here A register number is represented using the type int. In GCC, int requires 4 bytes of memory. So register number requires 4 bytes. Name, its type is character. So 1 byte. It is an array, 10 into 1. So name requires 10 bytes. Float fee, float, its size is 4 byte. So fee requires 4 bytes. 4 plus 10 plus 4 equal to 18 bytes. Clear? This is the memory representation of this student structure. Okay. Variable initialization. Structure variables can be initialized during its declaration. See the syntax. Structure name, variable name equal to value. Student s equal to value. Here the structure variable s is initialized during its declaration. So we can say structure variables can be initialized during its declaration. Next, accessing elements of a structure. Remember the dot operator. Okay, dot operator is used to access elements of a structure. See the syntax. Structure variable dot element. Example, s dot register number equal to value. Here dot operator is used. Okay. Here this value is directly assigned to this element. Cin s dot register number. This statement is used to accept the details through the keyboard. Okay. Now consider this code. Struct test1 int a float b t1 equal to 3, 2.5. Test1 is the structure name. Okay. T1 is the structure variable. Another structure, struct test2 int a float b, and its structure variable is t2. If we want to copy the value of t1, okay, into t2, we can use the statement t2 dot a equal to t1 dot a, t2 dot b equal to t1 dot b. Remember, t2 equal to t1 is invalid because t1 and t2 are of different types. t1 is of type test1, t2 is of type test2. Remember this code for the examination point of view. Okay. Now look at this program to find the total score of a student using structure. This program demonstrates all the concept that we have discussed so far. Clear? See header file, then struct student int register number, character name, int te ce pe, int total. This is the structure definition. Struct is the keyword, student is the structure name, it contains different elements. Okay. And in the main function, we can declare this structure. Student s, s is the structure variable. So student s, clear, the structure variable is declared here. Now we can write the statements to accept the details. Cout, enter register number. In the output screen we can see this message. Cin S dot register number. See, here dot operator is used to access this element, right? S dot register number. S is the structure variable and dot operator is used to access this element. Similarly, we can access name, TE, CE and PE. Okay. Cout, enter name. Cin S dot name. Cout, enter the scores in TE, CE, PE. Cin S dot TE, S dot CE, S dot PE. After getting all these details, we can calculate the total. S dot total equal to S dot TE plus S dot CE plus S dot PE. Then the final statement to display the result. Cout, register number equal to S dot register number, name equal to S dot name, total equal to S dot total. Okay, a very simple program. This program contains only one structure variable, that is S. Okay. Hence, the details of only one student can be referenced by this program at a time. If we have to deal with group of students, we will use the concept of array of structures. See the example. Program to find the total score of a set of students. Struct student, int register number, character name, int TE, CE, PE, int total. The same structure definition. Okay. In the main function. Student S of 10. See the difference here? Here array of structure is used. Int n comma I. Enter the number of students. Cin n. Here a for loop is used to accept the details of each student. Okay. Cout, enter register number. Cin S of I dot register number. Cout, enter name. Cin S of I dot name. Okay. Cout, enter the scores in TE, CE, PE. Cin S of I dot TE, S of I dot CE, S of I dot PE. After getting all these results, we can find the total. S of I dot total equal to S of I dot TE plus S of I dot CE plus S of I dot PE. Then one more for loop is used to display the details of all the students. For I equal to 0, I less than n, I plus plus. Cout register number equal to S of I dot register number. Cout name equal to S of I dot name. Cout total equal to S of I dot total. Okay. Nested structure. See the definition. An element of a structure may itself be another structure. Such a structure is called nested structure. There are two styles of nesting. See the example. In the example 1, struct date. Its elements are day, month and year. Okay. Another structure student. Its elements are register number, name, DOB and fee. Here in this example, the two structures date and student are defined separately. Okay. And the student structure contains a variable DOB of type date. That means date is a structure. That is the nesting. In this example 2, here the date structure, okay, date structure is defined directly inside this student structure. Okay, that is nesting. Note this definition of nested structure and these two styles for the examination purpose. Okay, shall we move to the questions? Question number 1. Define a structure to represent employee details. Employee details are employee code, name, date of joining, and place of employee. Okay, the question is to define a structure. And second question, define a student structure with the following details: name, register number, and height. Declare a variable to refer to the details. Also draw the layout of memory allocation. Okay. And third question, what is nested structure? Write an example. Try to find out answers of all these questions. We'll be discussing the answers in the next session. Till then, bye.